Now we are looking, if we're given the present value or the principal and the interest rate, convert that to 0.0226, as well as compounding quarterly, that means that M is going to be 4, showing up both here and here. We want to find out how long the money was invested for. And if needed, round to the nearest tenth of a year when we're done. Okay, well, let's see here. Plugging those things into that same formula we just used in number 6. Again, I is equal to R over M, and N is equal to M over T. So I tend to just go ahead and plug those in, because when we follow the order of operations, this chunking up into 3 different smaller formulas, rather than seeing it as one single formula, you're going to be applying this stuff according to the order of operations anyway. Okay, so I'm going to divide by 4. And let's see here. Add the 1 inside the parentheses. Now, what I'm going to do after that may be a little different from what you've seen. So let me get that to show up here real quick, and we'll address that. Okay, almost there. All right. Our variable t is up in the exponent, which means we want to take a natural log at some point. What you cannot do, you cannot multiply the 1225 to this, because the 1225 is not influenced by that 4t. So I need to isolate the exponential parts. And let's see. So I divide both sides by 1225. Now we have this exponential part. And give me just a moment here. Okay, I've replaced what was inside with an X for sake of quicker writing. The only variable that you have is the t, but it's being multiplied by 4, and it's up in an exponent, where we need to take the logarithm of both sides to get it out of there. Well, you can make that perhaps a little bit easier if you remember that when 2 exponents are right next to each other, there's no other x in the way, you can multiply those exponents when we go this direction. So what I'm about to show, I've gone from here to here, so that I've got a number that we know raised to the 4th power, raised to an unknown power of t. Let's take a look at that. So what I'm going to do is figure out what 1.00565 to the 4th power is, take the natural log of both sides, and the t that I kind of isolated back here, I'll bring out in front of the natural logarithm as multiplication. So let's see here. When I do that, we get this multiplied to t. So that must be whatever we had with 1.00565 to the 4th power, and take the natural log of it, we get this. What we see over on the right-hand side is the result of the natural log of 1.25 something. So I'm going to divide both sides by this messy number. It's going to get divided into this messy number, and I'm expecting something a little bit bigger than 10, it looks like. Actually, a little bit smaller than 10. See what happens. All right. said to round to the nearest tenth of a year. So first off, I state what I get is exactly as the calculator gives me. And then when I take that 5 in the hundredths place, one place further than the tenths place, that's going to round that 9 up to 10, and that'll carry over to this. So 10.0 years.